Hi and welcome. Today we are going to talk about the DLT table, and we are going to start by defining this framework and why we use this concept to data engineering use case. And then we are going to define the CDC is the change data capture, and what is the true way to define the change of the data in our data platform.
DLT table is a declarative framework for building reliable, maintainable, and testable data processing pipeline. You define the transformation to perform on your data, and data table manage task orchestration, cluster management, monitoring, the data quality, and error handling. Instead of defining your data pipeline using a series of separate Apache Spark tasks, you define a stream table and materialized view that the system should create and keep it up to date. Delta table manage how your data is transformed based on queries you define for each processing step. You can also enforce data quality with delta table, which allow you to define accepted data quality and specify how handle record that failed those extraction. What are delta table dataset? Let's search to response to this question. A delta table dataset are the streaming table, materialized view, and view, maintained as the result of declarative query. For the streaming table, each record is processed exactly once. This assumes an append-only source. The materialized view records are processed as required to return accurate result for current data state. Materialized view should be used for data source with update, deletion, or aggregation, and for data change capture processing. How about the view? The records are processed each time the view is queried. Use view for indeterminate transformation and data quality check that should not be published to the public dataset. Now let's return and deep dive into a stream table. Is a delta table with extra support for streaming or incremental data processing. Streaming table allow you to process a growing dataset, handling each row only once, because mass datasets grow continually over time. Streaming tables are good for most ingestion workload. Streaming tables are optimal for pipelines that require data freshness and low latency. Streaming tables are also be useful for massive scale. Also transformation, as the result can be incrementally calculated as a new arrive, keeping result up to date without needing to fully recompute all the source and which is updated. Streaming tables are designed for a data source that are append only. And the materialized view or live table is a view where a result has been pre-computed. Materialized view are refreshed according to the update schedule for the pipeline in which they are contained. Materialized views are powerful because they can handle any change in the input. Each time the pipeline update, query results are recalculated to reflect change in upstream data that might have occurred because of compliance or correction aggregation, or a CDC. Delta Life Table implement materialized view as a delta table, but abstract away complexity associated with efficient application of update, allowing user to focus on writing a query. How about the view? All view in the Azure Databricks compute result from source dataset as they are queried, leveraging caching optimizing when is available. A delta life table does not publish a view to the catalog, so view can be referenced only with the pipeline in which they are defined. View are useful as intermediate query that should not be exposed to the end user or system. Databricks recommend using View to enforce data quality, constraint, or transform and enrich a dataset that drive multiple downstream query. Now let's detail the data life table pipeline. A pipeline is the main unit used to configure and run dataset processing workflow with the data life table. A pipeline contains materialized view and streaming data declarative in Python or SQL source file. A data life table infers the dependency between those tables, ensuring updates occur into the correct order. For each dataset, a delta life table are compare the current state with the desired state and processed or create to update the dataset using efficient processing method. The settings of the data life table pipeline follow into two categories. The first one is the configuration that define a collection of a notebook or a file. The second category is a configuration that control pipeline infrastructure, how updates are processed, and how tables are saved into the workspace. The most configuration are optional, but same query careful attention, especially when configuring a producing pipeline that including the following steps. To make a delta life available outside the pipeline, you must declare a target schema to publish the Hive metastore or a target catalog, and a target schema to publish into the Unity catalog. The second one is the data access permission are configured through the cluster used for execution. Make sure your cluster has appropriate permission configuration for the data source and the target storage localization. What is a pipeline update? A pipeline deploy infrastructure and a compute dataset when you start an update. An update does follow these following steps. Make sure that you are starting your cluster with the correct configuration, then discover all the table and view defined, and check for any analysis error such as invalid column name, missing dependency, and syntax error. Create or update table and view with the most recent data available. Pipeline can be run continually or on schedule depending on your use case, cost and latency requirement. How about the data ingest with a data life table? Data life table supports all data sources available in Azure Databricks. Databricks recommend using streaming table for most ingestion use case for file arriving in the cloud object storage. Databricks recommend autoloader. You can directly ingest data with the Delta Lake table from the most message buses. For the format not supported by autoloader, you can use Python or SQL to query any format supported by Apache Spark. How are Delta Lake table and Delta Lake related? Delta Lake table extend the functionality of a Delta Lake because table created and managed by a Delta Lake table are a Delta table. They have the same granularities and feature provided by a Delta Lake. A Delta Lake table adds several table properties in addition to may table properties that can be set in a data lake. Here there is some data lake table properties reference. For example, to configure your pipeline, you have a field ID is a string type, and you have also the name also is a string file, is user-friendly name for the pipeline. The name can be used to identify the pipeline job into the UI. The storage also is a string. The configuration is an object. This object is composed by key value pair. And then you have libraries is an array of objects, cluster, development, notification, continuous, target, channel, and others pipeline configuration. For the Delta Lake table properties, there is properties to auto-optimize that when is set true, that can be automatically scheduled optimize the optimization of this table. And the other calls is optional also. By default is set none. An option string containing a comma separated list for a column name to the order. This table by, for example, pipeline optimization, the order per years and months separated by a comma. The data pipeline reset allowed. By default is true that control whether the full refresh is allowed for this table. There is some limitation of the Delta Lake table. The first one, all tables created and updated by a Delta Lake table are a Delta table. We are always related to the Delta table. The second limitation is the Delta Lake table can only be defined once, meaning they can only be the target of a single operation in all Delta Lake table pipelines. The third limitation is identify columns are not supported with the table that are the target of apply change into and might be recomputed during the updates for materialized view. For reasons, Databricks recommend only using identify column with stream table in a Delta Lake table. And the last limitation is another Databricks workspace is limited to 100 concurrent pipeline updates.